Question 18. Give all the prime numbers less than 40. Now, we're actually going to go one better than this, and we're going to give all the prime numbers up to 100. And we're going to use a method called the sieve of Eratosthenes. Now, Eratosthenes was a Greek mathematician who lived 200 years before Christ, 200 BC. And a sieve is like what you might find in one of your kitchen cupboards that's got lots of tiny little holes in it that allows things like sugar or flour to pass through the sieve to filter out. It's like a filter. It filters out like the lumps in the sugar or lumps in the flour or whatever. So what we're going to do is we're going to use this to filter out the prime numbers. So the prime numbers are going to be left, and it's like the ones that are not prime are going to fall through the holes and filter them out. So this is what we do. So we start with a number 1. Now, number 1 is definitely not prime, because to be a prime number, you need exactly 2 different factors. And the only way of making 1 is 1 times 1. And that's not 2 different factors. That's the same factor twice. So 1 is definitely not prime. So we cross it out. Now, 2 is prime, because the only way of making that is 1 times 2. And that is 2 different factors. So we're going to circle 2. But then every number that's in the 2 times table after 2 is not going to be prime, because it'll have 1 in itself as a factor, but then all the even numbers will also have 2 as a factor as well, which means they can't be prime because they'll have more than 2 factors. So we can cross out the number 4. So everything that's even now, 2 is the only even prime number. So 4, 6, 8, 10 will not be prime. In fact, anything that ends in a 2 won't be prime. So you can cross out all the ones that end in a 2. There we go. Anything that ends in a 4 won't be prime. So 14, 24, 34, 44, 54, and so on. Anything that ends in a 6 won't be prime because it's even. And 2 is the only even prime number. Anything that ends in an 8 won't be prime. So 38, 48, 58, 68, and so on, all the way down. And anything that ends in a 0 is not prime. Because, again, it's going to have 1 in itself as factors, but it's going to have at least 2 as a factor and something else that pairs up with 2 as well. So, like 70 will have 2 times 35 because 2 pairs up with 35 to make 70. Now then, we're going to get a different colour. And we're going to move on to 3. Now, 3 is definitely prime because the only way of making it is 1 times 3. That's it. But then everything else that's in the 3 times table after 3 is not going to be prime. So if we just count up in 3s now, so 6, and cross out anything that's not already gone. So 2 3s are 6. Well, that's already gone. It's not prime. 3 3s are 9. So that can't be prime. Add another 3 is 12. That's already gone. Add another 3, 15. Add another 3, 18. So I'm just going up in the 3 times table. 21's not prime. Another 3, 24. Some of these have already gone. Some of them haven't. So if they've already gone, you can cross it out again if you want. If they haven't gone, you need to cross it out. So 27 won't be prime. 30. Another 3, 33. 36. 39. 42. 45. 48. 1, 2, 3. Another is 51. So another 3, 54, and 57, then 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, 99. So that's all the 3 times table gone. And then as you can see, we skip 4 because we've already decided that's not prime. Now you move on to 5. So 5 is definitely prime because the only way of making it is 1 times 5. But then everything else after 5 that's in the 5 times table is not going to be prime because it would have 1 times itself and then at least the number 5 as another factor. So 10's not prime. That's already gone. 15, 20, 25 hasn't gone yet, but cross it out now. 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So 5 is the only number in the 5 times table that's prime. Now we come to one that's a bit of a trickier one, the 7 times table. So 7 is definitely prime because the only way of making it is 1 times 7. But then anything else after 7 in the 7 times table is not going to be prime. So 2 7s are 14. Cross it out. It's already gone though. Another 7, 21, already gone. Another 7, 28, already gone. Another 7, 35 is already gone. 42's gone. 49 hasn't gone, but 49 is not prime because it's got 1 times 49 and 7 times 7. So 49's gone. 56 is gone. 63 is already gone. 70 is already gone. Plus another 7 is 77. So 77's not gone because it's 1 times 77 and 7 times 11. So add another 7 to 77 is 84. That's gone. Add another 7 is 91. That's gone. Add another 7 is 98. That's gone. And now the beauty of this is the numbers we've got left. So we filtered out through the sieve all the numbers that are not prime by crossing them out. And the ones that are left, the ones that are circled, are the ones that are prime. Or the ones that we haven't, we're going to circle the ones, but we're just going to do the 11 times table. 11 we know is definitely prime because it's 1 times 11. And I think, so 11's definitely prime. So 22's already gone, 33, another 11's gone, 44, 55, 66, 77, 88, 99. And actually, that's it now. We don't need to do any more. So all the numbers that are left, and I think I'm just going to highlight them in yellow, all the numbers are left are the ones that are prime. So 2 is, 3 is, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Now, it does say all the numbers less than 40. So for the sake of this question, they would be our answers. But if we sometimes on SATs, you have to go up to 100. So we'd better just highlight all the rest up to 100. Good to be aware of these. These are all the prime numbers. So just to recap, what we're saying is that any number we've highlighted in yellow only has 2 factors. So 53, for example, the only way of making it is 1 times 53. 73, the only way of making it is 1 times 73. So they are all the numbers less than 100 that are prime.